Hi everyone, welcome. Today we are going to show you a demo of the project called skin cancer detection using deep learning. So as you can see on the screen, this is the final product where you can upload any skin cancer image, where you will get which disease is that and with how much accuracy we are able to predict and what is the cause and what are all the possible treatments available for the skin cancer detection. For different type of skin cancer, we have built this complete web application. And here you can see different model codes which we trained, which we built, and where we get accuracies, graphs, pre-processing, and everything is being done from top to bottom, from dataset collection to pre-processing, model building, analysis. Then you choose the best model and then you integrate it to web application. So this is a full web application with which we built with help of HTML, CSS, JavaScript, and we'll be showing you exactly what we done, how we done, and what methodology we try to approach to get all these things one by one. But before that, we'll try to do a small research on what is skin cancer detection and what is its importance is there in the research field, and why we need to use AI technology in the skin cancer field. Will it gonna help? So all those things we'll discuss one by one, and then we will discuss in depth what are the existing papers. We will gonna refer three IEEE papers one by one, which are very recent, and we gonna analyze what are there in these papers, and then based on the existing paper of all these three papers, we gonna define our proposed methodology, which is far better than this. Then we'll analyze, then we'll cross check, okay, our accuracies and their accuracies, our losses and the existing paper losses, and we'll try to cross validate them, and why we are getting the better result, that also we will prove. Okay, our methodology is better than the existing methodology, we will prove it. So first we'll discuss about, so these are the three papers, 1, 2 and 3 IEEE research papers which we are referring. Okay, you can check, you can cross check them. Okay, you can have this DOI number. If you just call us to the given number below, we will help you with all these things. We'll provide you the papers, we provide you the codes, we provide you documentation, we provide you a support, and according to the requirement we will try to charge. Okay, where if you need only basic synopsis and document, we will provide it. Okay, and then if you want a complete project support also, we will provide it as a full expertise team. We can help you from A to Z of the project, and we will be helping you in the procedure. It means once you take the code, if you have any minor changes, if you want any minor improvements, or if you are having your own methodology which we defined, we'll work according to that. Otherwise, if you ask us to define something new methodology than the existing that already we have built, not other than these papers, again we can do whatever the changes you want for. First of all, we'll discuss what is skin cancer, and then we'll discuss one by one the stuffs. So skin cancer is nothing but it is an abnormal growth of the skin cells. And why it happens? It happens because of the sun rays, UV rays, the DNA of the skin cells will get destroyed or manipulated. So that manipulation makes that cells uncontrollable. So the growth of that particular cell will become uncontrollable and it will try to spread. So that's what will form a tumor. So this thing we call it as a skin cancer. It can happen on any part of the body. There is not a rule like it should happen only in the exposure area of the body to the sun. It can happen. UV rays can penetrate through your clothes. Okay, and how it develops actually. So I mentioned you, once the existing skin cancer cell DNA is being getting damaged, so that damaged cell will now will grow uncontrollable, and our body can't repair that damage, or that damage happened to the particular cell because of the UV rays. What are the main reasons for this? One of the most common reason is UV exposure. and then it may happen because of the genetic predisposition. And then fair skin tone, that means white skin tone, and weakened immune system is also one of the most important reason. Where your immune system is very weak, that will lead to a weak uh, protection against the disease, okay, which will spread all over the body. Exposed to radiation and harmful chemicals, and this can happen even to the people who are exposed to the harmful radiations, like you may heard about Hiroshima, Nagasaki, those things, okay, like those radiations which even affect till today also. And some chemical exposure, that also will lead to like this skin cancer problems. And if this will even come to genetical also, as I mentioned the second one. So family history is also one of the most important stuff. So that genetic predisposition, genetical carry, okay, both of them are the reasons. What are the precautions we can take? What are the things that we can keep in our mind to avoid all these things? Is using a sunscreen and avoid midday sun. It means avoid, try to walk on daytime or evening time to avoid the afternoon time to reduce this, okay. These are the precautions. I know like some people can't avoid it because they will be need to work entire day outside, so some people can't avoid it, but whoever can avoid it, they can avoid it uh, by coming out, okay, where there is a high radiation intensity in which area. It doesn't mean like you should not walk in any area, okay. It's like some areas will be high intensity, okay, UV rays will be very high, where ozone layer will be very weak. In that cases you should take a precautions, or wear protective clothing like UV blocking sunglasses is also one of the most common thing people will prefer to. And avoid tanning beds. Perform regular skin self exams, so you need to cross test it again and again. And try to visit dermatologist, uh, okay, the expert in the skin thing. Type of skin cancer that are available are basal cell carcinoma, BCC, most common, okay, but it is very slow, it is very low level, it won't rarely spread like other skin cancers, whereas squamous cell carcinoma can spread if untreated. So whatever we are discussing from top, they are bit low effective, but when it comes to melanoma, most dangerous, aggressive and likely to spread. Merkel cell carcinoma rare but very aggressive. Actinic keratosis, precancerous lesions that can develop into SCC, that is squamous cell carcinoma, it can turn into, but actinic keratosis is again very lowest stage we can say. So when we understood about different type of skin cancers, what are the treatments are available? It depends on the size and stage, which stage that skin cancer is, okay, and location of the cancer, on which body of the on which part of the body the cancer is being caused. Based on that, the treatment will be decided. So few type of treatments are surgical removal, cryotherapy, radiation therapy, topical treatments like using cream, chemotherapy using chemicals like almost like a creams, targeted therapy or immunotherapy. By increasing the immunity of the person also we can reduce it, or targeted therapy also can be done. That is normally immunotherapy itself. So make sure the immunity of the person is improved to fight against the cancer. And one more thing we should understand, why we are discussing all these things is main stuff is the cost of the treatment. Okay, so in which stage how much cost it will become, for what type of treatment, how much cost is there, average, not telling exactly. So in India, basic treatment, basic surgical treatment ranges from 20,000 to 80,000 Indian rupees, whereas advanced therapy in India will cost around 1 to 5 lakhs. Okay, and chemotherapy will be 10 to 50,000 per cycle. whereas in USA, surgical removal itself will cost $2,000 to $10,000, whereas most surgery will cost $3,000 to $15,000, whereas advanced melanoma treatment is far away. Okay, so it is around 1 lakh. Okay, $1 lakh. And we'll discuss about the statistics. So why it is so much dangerous, why we need to work on skin cancer, and why we are trying to do a research, do a technology which can help us to improve the detection and cure of the skin cancer. Is it's a the statistic of this skin cancer is like over 3 million non-melanoma skin cancer causes globally per year, and 3,25,000 new melanoma cases and 57,000 deaths worldwide. Non-melanoma is 3, but melanoma itself is more than 3 lakh, 30 lakh, that is 3 million is non-melanoma. Among them 3,25,000 is melanoma, so which is very deadly and very dangerous. And deaths are happening 57%. You see, 57,000 deaths worldwide annually is going on. So in India, around 50,000 to 70,000 new skin cancer cases annually are coming. In USA itself, it's over 5.4 million cases for non-melanoma and nearly 1 lakh melanoma cases each year for USA, which is not a good sign. So all these things we discussed. Now we'll discuss how our deep learning can help here. In what manner our deep learning can help us to overcome all these things. So we are trying to use deep learning models like DenseNet, ResNet, EfficientNet, MobileNet. So these are the classification problems. These are classification models that we are using. What is their benefit here? One of the most important benefits is automatically detects and classifies the type of skin cancer. So when we understand what is the type of skin cancer, it will become very easy to decide what treatment can be done. So the right classification and the right treatment will be able to reduce the time as well as cost, and it will be effective treatment, so that may reduce the death counts. So, and here one more thing is human error, because so many type of cancers are there. As a human, we can't keep that thing in our mind, like multiple things at once. So we may do something wrong, so that human error can be reduced, because these models can understand lakhs and lakhs of data, millions of data can be understood by a model, and it doesn't get confused with any number of data you feed. So that will be very accurate. And what is its purpose? Main purpose is early detection, the right classification of the cancer at early stages, the type of cancers can able to solve the problem and will increase the survival chances. Because if we can able to detect right, I classify it as a right, like which condition is that, we can treat it in easiest manner. So anyway, it will increase the survival chance. It will work remote and rural areas via web and mobile applications where can't reach, where they can't afford. For them also it is very helpful. Actually nowadays the matching will happen, they will take a sample, they will match, and they will do manually. So better than that, our models performs a lot better in that case. So now what we are trying to do here is, now we understood what is the importance of this skin cancer, what is the data of this skin cancer, why it is so much important, why we need to work on this, and how it impacts in the real world, and whatever we are doing, our work is worth it. We wanted to prove that. Now we will speak technically. So now we understood theoretically what is that and why we are doing. So now we'll understand those papers one by one, those three papers. Can you see this paper? One paper, two paper, and three papers. So I have gone through all these three papers. We have made a proper documentation what this paper contains. If you go through the papers, mainly you should check it like a methodology section in proposed system or proposed method system. Here only you'll get all those stuffs what this paper is trying to use, and okay, and what are the results they are getting, which data set they are using, what is accuracy, what is the loss, what is the model. From this paper we have collected all of them and we made it as a document. So now I will going to check these papers one by one. First paper we'll see. Yeah. So CCIP, the skin cancer detection using deep learning 2022. So this is that paper. Okay, so about what this paper is speaking, I'll see. Okay, so I will open that here also. This is that paper. Okay, now in this paper it is working with a dataset called ISIC dataset, International Skin Imaging Collaboration, the dataset name, and original size of the dataset is 2357. You can see the same thing here, 2637, 2537. Actually they will split it into train and test. So if you open their paper, if you scroll down here, their methodology, you can see which data set they are using. 2357. Understood? 2357 photographs of the benign and malignant images are being used with in this paper. Okay, so whatever I written there, that only ISIC. So I wanted you to confirm that I'm using this information in that documentation. So I want to make sure you understand that. Okay, so now 2357 images are there, and within that there are 9 different classes of the images: basal cell carcinoma, dermatofibroma, melanoma, nevus, pigmented benign keratosis, seborrheic keratosis, squamous cell carcinoma, vascular lesion, and actinic keratosis. 9 different skin cancers are there. This is one of the most used data set available. So, and after discussing all these papers, I will define our methodology. Okay, don't skip. All these things we'll discuss one by one, then only we'll understand why we need to work on this. Okay, why it is very important. So if you don't know existing system, how can you propose something? And then in pre-processing, this paper speaks about data augmentation. Okay, and they are creating around 6750 images out of 2357. So they are applying augmentations like rotation, quality reduction, and other some synthetic transformation as mentioned in that paper. So they are not openly sure which is that transformation. Actually that paper doesn't give us the detail. So they say we are using other synthetic transformation. It can be anything. It can be a flip, it can be increasing enhancement, it can be anything like that. And then train test split, they are using 539 to go for training 80%, testing 20% they are using 1347. And the CNN model they are using is they are trying to build their own CNN model from the base. They are going to use custom CNN model according to these details. Okay, whatever they are mentioning here, according to these details, they are using their own custom CNN model with all these hyper parameters, I can say. Different layers, what are the different layers they are using? Okay, and then input set 180 bass is 32, and different optimizers they are trying is Adam, STD, RMS prop, and NADAM. So these are loss reduction like functions. We call them as optimizers, which will try to increase the accuracy. So if you compare, if you want to compare, you can use the multiple. And hyperparameter tuning, what is that we are trying to change? Tuning nothing but understand changing some parameter, some variable with different numbers. With tuning, they are getting around 69.12% training accuracy, which is very worst, I can say. It is not a good number. Finally, this paper provides us that with Relu, Sigma and Softmax as a combination, they are getting at most 90% training accuracy. Testing is 85% at best. It is not going beyond that. Because this is existing first paper, their accuracy is 90, but whereas our accuracies are minimum crossing 90. Testing accuracy, training is crossing 95. This is first paper. So then I'll go with this next paper, 2024 paper, so which is very new, and their accuracy they are highlighting 89.7%. Okay, they are openly highlighting here. And then we'll go with the next paper. This paper again, it will try to use ISIC, the same data set 2637, and they even do image data generator, that is image augmentation. Both the papers are discussing about image augmentation, and this paper mainly they are including rescaling, shear range, zoom and horizontal flipping. If you are not pretty sure what are all these augmentation and all those things, I will discuss in the end of the discussion about these papers. I will discuss about those theories, what are they and why these papers are doing like this. I'll discuss. And under pre-processing, and that they are using a reshaping, resizing, conversion to array, and that's all. Zoom, they are augmentation techniques. Under pre-processing, they are not going in depth. Even both the papers, if you see, they are not doing much pre-processing. They are applying augmentation. Augmentation is applied to increase, to balance the data set, but they are not pre-processing images to highlight the region of interest. That is missing in these two papers. What are they? I will tell you. And once they build their CNN architecture, their maximum training is 86. Okay, and yeah, so that's all about that particular paper. So that is third paper, right? Yeah, this paper, whatever we saw just now. This paper, no, previous paper, second paper, sorry. So now we'll go with the third paper. So this paper again uses only two classes, benign and malignant. It doesn't take in depth for multiple classes, only two folders, only one at 00 JPG images. So this data set is the heart of the entire work. So this paper is working on only two different classes. It is not working on multiple classes. It will say whether it is benign or malignant. It won't say whether it is actinic keratosis. So that is a failure of this paper. That is a research gap available in this paper. Only two classes, and they are pre-processing like rotation, width. Again, these are the augmentation things. They are not working on image enhancement, image region of interest highlighting, or making the image better. They are not doing any effort to do make it better. They are only applying augmentation to increase the number of images. Model is DenseNet 169, and these are the custom layers they are using. I'll tell you what are these custom layers, what is this custom CNN, what is transfer learning. I'll discuss all of them while I will discuss our proposed methodology. I'll discuss everything. So these are the hyperparameters for the training. Once they train it, they are getting 91% precision, 94%. It means almost 90%. Almost 90% is a final accuracy, you can say. But according to them, they are openly mentioning like 89.7 as a big number. Okay, they are already mentioning here itself. Okay, 89.7 as a thing. Okay, and okay, this is a confusion matrix for that. AC ROC curve 0.9656 is there, but that is not an exact accuracy. Okay, their test accuracy is the most important thing we should consider, 89.7. and DenseNet 169, and they use some other models also, but they were getting very less accuracy for them. So you understand 89% is very high. Then what about these VGG, ResNet and CNN? they will be having very low than 89%. So their accuracy is not at all crossing 90. It is below 90. Same, and again, these people are using only 2 classes, this paper mainly. Okay, so whatever these 3 papers we now saw or done a research over them, those papers mainly concentrating on CNNs, custom CNNs, but whereas last paper is taking transfer learnings. But this was working on only 2 classes, not multi-class. So remaining were multi-class, okay, multi-class, but normal CNN. Again, they are using augmentation. Both, all of them are using augmentation. I will tell you why to use augmentation. What is augmentation? Why they are doing it, and why we should also do that. That's the most important thing. Then what they are not doing, what we are doing extra. Okay, all these things will provide. First, I will explain about this augmentation. For example, what they are doing is, for example, here there is one skin cancer. This is a data set which is having subfolders: skin cancer, actinic keratosis, and some other thing. So all of them will be having images like this: 2000, 1000 images within them, 500. So when you see, that is imbalanced data set. So you can't work with imbalanced data set. You won't get good accuracies. So they must be balanced like equal number of images in each folder. So that's what these papers are concentrating mostly on, and that should be done. They can't skip it. So for that, what they will do is, they will take one image, okay, and they will rotate it to the few angles, and they will zoom it, okay, they will zoom in or zoom out, okay, they will flip it right to left, left to right, flip it. So they will create a new image like this. Okay, you see, this becomes a new image from this, but the same image, but variation are induced in it to create a new image. So now I can make sure all of them are having 5000 images by creating like that. We call this augmentation. But what they are doing only augmentation. Again, I'll tell you what is custom CNN and what is transfer learning, and what is the importance of transfer learning also I'll tell you. For example, let us take, all CNNs will be having a stock of layers, okay, convolution layer, max poly, dense, dropout, all those things. So now I'll give one example, small real world example. Let us take, there is a person A and person B. Now assume like person A doesn't know anything about martial art, whereas person B know about karate. Now I want you to train both of them for kung fu. Okay, I want you only to train about 2 weeks. Within 2 weeks, if you train them, both of them, who will learn better? Almost we will overtake. Maybe it won't know kung fu, but it know karate, which is similar to kung fu. So we can manipulate his techniques to learn kung fu, and we can make him better within 2 weeks. I'm not saying this custom CNNs are not better. This we call it as a transfer learning. So transfer learnings are always better than the custom CNNs, where we build ourselves layer by layer by layer. Okay, so they will work faster and they will work better. So normal CNNs will work, but the time taken is very high compared to transfer learning models. So that's why we need to prefer transfer learning to reduce the time, to get a better accuracy. Okay, so in our case, which are transfer learnings we are working with? One is EfficientNet B0, okay, ResNet 50, and MobileNet. 3 different models we are building, and for 3 models we are getting better results. That I already shown you at the start of this video. You can see here, for EfficientNet I'm getting training accuracy 98, as well as validation accuracy 92, which is far better. Whereas MobileNet, it may be little bit less, but again you see training accuracy is 99. If you train it further, it will increase. It is in increasing mode. If I trained only for 30 epoch, if I train it for 50 epoch or 100 epoch, this validation accuracy will increase to 95 without fail. And ResNet 50 also we have trained, again it is in increasing mode, so it is 98.99, and it is 84. We can make sure it will also be increased to above 90 minimum, but among them the best one is efficient. Okay, even if we train it for 100 epochs, so we'll even get the better result. So that's what we are defining. We are defining our transfer learning models rather than custom CNN models to get a better accuracy. That's why we are getting better accuracy. And augmentation, I told you, what are the augmentation we are defining? We are also defining the augmentation techniques like rotation, zoom, flip, all those things, and we are creating more number of images for each class. I will tell you how many number of images. Can you see here? So we were having less number of images each class. Now we made it to 1000 into 9,000 images, which no paper is discussing about those many number of images. So we are creating 9,000 images for total 9,000 images, which is very used. It is not that much easy to work on like this used data set. So we have balanced it. That's what I am trying to show you this graph. We have balanced our data set with augmentation functions. Okay, you can see our augmentations. We can even define according to your requirement what augmentation technique can be used to increase the data set size without inducing much noise. You should not induce over noise while you augment it. And once we are done with that, we need to do pre-processing properly. So that paper, whatever the paper we have referred, no paper is discussing about the techniques. That is mainly on pre-processing techniques. What pre-processing they are using. Are they making anything better there? No paper is discussing about it. So what pre-processing techniques we are using is like Gaussian noise blur removals, which we use to remove the noise in our images. To highlight histogram enhancement techniques are used to make our images better looking. Okay, so just I will try to show some Google images so to understand what impact it will bring. So for example, if you see here, CLAHE will increase the quality of the image. So using this, we may get better results. So we are using the CLAHE. We are making our images to look better, to highlight the region of interest. And then Gaussian blur. This is used to remove the noise, remove the salt, pepper noises or small noises in the images, which no paper is discussing about. So we are trying to make these things better. And what we are doing is so we are trying to apply Canny Edge Detection like this. We try to make edges of the images sharp and highlighted like this. Some Chrome images I am trying to show you and make you understand what is the importance of what we are doing, what pre-processing we are doing, and we are doing it in a proper sequence manner. They are not random. So for some purpose. So that's why you see here in our project, our images looks a bit different. These are not original images. These images, after we apply multiple sequence of pre-processing and we highlight the region of interest. So that region of interest makes our model to learn easily and better. That will increase automatically accuracy of the model. This should be done. So without pre-processing, without highlighting, without filters, you won't get a better result. So that also we have done. We have applied multiple pre-processing techniques over the images. And then as I mentioned, we are using well tested transfer learning models with good hyperparameters. Good hyperparameters we are using. That's why we are getting all the models above 90-95% accuracy. And they are all based on same dataset. Almost we are using the same dataset these people are using. Again, we are not using some random dataset and we are getting good result. We are using the same dataset, same ISIC dataset, and we are getting the results for that. Now what I will do is I will go to that website and I will show you how it is working, and we'll see the demo of it. So this is skin cancer detection using deep learning project. Then this is the home page of it, and when you click here, you'll get an option to choose a file. So you can upload any skin cancer images and it will give you answer like this. which type of skin cancer is that, and what is confidence score, with how much confidence, with how much accuracy, you can say confidence for this. Okay, 99% confidence it says this particular is actinic keratosis, and what cause, okay, what is the treatment, they also can be recommended. That's a treatment recommendation for skin cancer using deep learning, we can say. Even we are mentioning what treatment can solve the problem. You can upload multiple images and you can check it. Okay, actinic keratosis, you can bring up any images of that test samples, and you can insert here and get the results. So we are getting much better result. So all these codes are done. Okay, all these papers are there. We'll be sending these papers and we'll be helping you with the synopsis. You can see all these codes. Okay, we have done HTML codes, we have done CSS, images, JavaScript, all those things are there. And finally we code our front and backend. With our for Flask we use for backend actually. So you can see the backend codes. Okay, these are the small databases for our different diseases and treatments. So all these things we have done. We have done front end code, back end code, we have done notebook files, we have built the model, we have saved the model. You can see EfficientNet code, whatever we built, we save the model there, we load it here, then we detect the type of cancer. So if you need full code documentation support, you just need to call us to the given number below, and we'll be helping you with the complete procedure, and accordingly we'll try to charge. So yeah, this is the end of this video. If you like this video, please click on the like button and you can subscribe us. We'll be coming up with few more good topics, and even you can refer to your friends, colleagues, okay, who are in need of these projects. And thank you very much. We'll see you in the next session with the better video. Thank you very much.